Welcome, dear students, to ECS 514 Course on Compiler Construction. This is your instructor, Muhammad Nawaz. And let's take a look at the agenda for the week. So this is week number 5. And today in this lecture, we are going to look at the following topics. So talk about regular expressions, finite automata, and the two different automatons, the DFA and the NFA. And we are going to compare and contrast them. It's a kind of review for all of you. But the new thing is this Thompson construction that we are going to look at. So it begs the question that why do we need to study this concept that we already studied in the previous course called finite automata? And that's a valid question because in the course of finite automata, you have studied this from a pure theoretical computer science sort of view. In this particular week, we are going to look at the regular expressions, the DFAs and NFAs from a very practical approach because we are going to use them to implement the lexical analyzer. And how do we do that? As I mentioned in the previous week, that we are going to create a lexical analyzer based on a tool which is called the FLEX, stands for faster lexer. And we will feed regular expression to the tool, and that tool is going to magically produce a lexical analyzer, which is the source code for the lexical analyzer in C or C++. There is also a tool called JLex, that means lexer for Java language. So it's going to produce the lexical analyzer written in Java language. But because this is a very important course and we need to know that how that tool internally convert that regular expression and does something to that using these DFAs and NFAs and then produce the tabular sort of data structure in C or C++ and produces the lexer. So that tool internally takes regular expression that will provide in a specific format, which is called the regular expression extended format. And that tool is going to then create from that regular expression an NFA, and specifically epsilon NFA. And then it converts that NFA to a DFA. And then that DFA is actually coded in sort of matrix form, in a tabular form, and a C++ code is generated, which is a complete lexer. And we are going to see that in the demo as well. So we need to go through this process in order to understand that how this automatic generation of the lexical analyzer is possible. So for that matter, we're going to study these concepts again. And you are going to also have the opportunity to see that why did you study those theoretical concepts of regular expression, finite automata, DFAs and NFAs. And later in the course, by the way, we are going to again use the context-free grammar that you studied in finite automata, and you're going to see that how it can be used and how powerful that concept is to sort of check the syntax of the language. So how to describe the token? We're going to begin with this question, and a token is again sort of a meaningful unit of characters in the source code. There were different token classes like the identifier, the keyword, the operator, the punctuations and all that, constants for example. So how do we describe tokens? And there were two possibilities in the previous week. We saw the ad hoc implementation. That means we were writing programs, we were building logic in C++ and design different functions for identifier and for keyword and for all that stuff. Because we want to use the regular expressions, we need to talk about languages. Because the primary purpose of regular expression is to describe a language, and a language is a set of strings. And each word in the language is composed of some sequence of characters. So there are broadly speaking, two categories of languages: the natural languages, the languages we humans speak and we communicate with one another, and then there are formal languages. So the difference between these two, based on my study, is that the natural languages are sort of they come into being when humans communicate with one another. So the rules are set for the language later so that the native speaker, the person who doesn't understand your language, can then learn your language. For example, in order to learn English, we need a grammar, we need a set of rules, right, which describes that what kind of words can we use and how can we use them, in which arrangement, for example. So the natural languages come before the rules are set for the language. That's how the human languages came into being. But for formal languages, we first define the set of rules that what will be the words in the language and how would we actually combine those words together in some manner to produce some useful statements or sentences. So irregular languages is one of the formal languages, and they're the most popular for specifying tokens. So remember that tokenization is not just limited to programming languages. There are lots of applications of tokenization where you need to divide the string of words into different tokens based on some sort of delimiter. For example, if I write a sentence and I want to separate each sentence based on the period or the full stop. So the full stop is called the delimiter, which divides two meaningful units from one another. Another very popular example of the delimiter is the space. So for example, if you write a sentence and the sentence is basically is the composition of words. So each word is separated with a space. So based on the space, I can divide the string words, and that is called tokenization based on the space. Similarly, we have a comma separated value, for example. We could divide those words based on the comma. So whenever we find a comma, we get one word. We ignore the comma, we read another word up to another comma, and so on and so forth. So this process is called tokenization. And if you recall, in the course of database management system where you used to write SQL queries, there is a specific format of each query. For example, the select query, the delete query, the update query, and there were clauses and there were keywords like the programming languages. So tokenization or lexical analysis play its role in other areas of computer science as well. So now the question is how to describe the tokens. So regular languages are the most popular because regular languages, as we are going to see in just a moment, are described by regular expressions. And regular expression is basically a kind of pattern between the sequence of characters. And if any string matches that pattern, we say that this string belongs to that language defined by that particular regular expression. So it's very simple and useful theory, and it's easy to understand. Probably regular expressions you would have encountered, simpler than most of the concepts in finite automata. And its implementation is very efficient as far as the lexical analyzer is concerned. So when we generate the lexical analyzer based on the tool, and the tool is actually using these regular expressions to describe tokens, that implementation is very efficient. That means the lexical analyzer doesn't take much time, right? So let's talk about languages now. So a language, in order to create a language, I'm talking about the formal language, we need a set of letters, a set of symbols, kind of. And from those symbols, we can then form words, and from the words, we can then form sentences. So the set of symbols from which a language is created is called the alphabet, and it's usually represented by the sigma, which is a Greek symbol, but here, unfortunately, I use the S symbol. It doesn't matter. Anyway, the concept is that an alphabet is a set of letters or a set of symbols or a set of characters. And from those set of characters, then we can create words, and we say that this language is defined over that alphabet. So a language is a set of string of characters drawn from S, or it is defined over that alphabet. And each word, by the way, from that alphabet, each word must be constructed. Each string must be constructed from those set of letters. No other letter other than the set. Examples of languages is the English language, of course, and the alphabet for the English language is the characters from A to Z, capital and small. So from the whole dictionary of English is composed of these letters. So if you pick up any word from the dictionary, you will find the same set of characters from A to Z, right? So the alphabet for the English language is that set of characters, and the language is, of course, all the words and sentences from that alphabet. Any programming language, you pick up any modern programming language, you would find all the characters in the ASCII character set. So the ASCII is the alphabet for the programming languages. So language is a set of strings, a finite sequence of characters, and from those characters we form strings, and those strings belong to some language. So we need some sort of notation for specifying which sets we want. And for that, we are going to talk about the regular expressions. So for lexical analysis, we care about regular languages, and regular languages can be described using regular expression. That's actually the definition of regular languages. A regular language is a language which can be described using regular expressions. Let's check the time because I don't want to have a longer video, so we're going to resume from here.